Right? If you look at that one, we stopped at cumulative frequency using the step diagram. The step diagram. Actually, what we actually said is that the step diagram, if it is connected with the cumulative graphs, step diagram is to do with the discrete data. Discrete data, you know, is the data that takes the form of digits. That's discrete data. Like 1, 2 is discrete. But now let's look at cumulative frequency polygon and curves for grouped data. For grouped data, they want to see what this group data is all about and how the graphs will appear when you look at given information on or data based on group data. Now let's see from there. Let's look at the first page that you have, where they talk about consider this situation. Are you there? Are you there? Consider this situation. Right? Yeah, consider this situation where we have got 6 weeks after planting, the heights of 30 broad beans plants were measured, and the frequency distribution formed as follows. Right?
Yeah.
Yvonne, are you there? Huh? Yeah. That. Yes, something like that. That I just did for a thing. All right. Okay. Now, so 6 weeks after planting, and the heights were recorded like that. The height in centimeters, x centimeters, we have got the 3 less or equal to between 3 to 6, which is 23 and 5. 6 is not inclusive, but 3 is inclusive to 5, where they're looking at the height from 3 less or equal to x than 6, like this one. What means there is we are looking at the numbers up to from 3 inclusive, and here is 5. The frequency was 1, so this is the height. So you had the height here, you had the height there, and then when you have that one, the frequency here was 1. This is the frequency. But that table, the frequency was 1. Between 6 inclusive 6 and 9, well, 9 is not 9, that is 2. 2, in other words, less than 9. Less than 9 is 2. Then the other one, 11, 10, 8, 5, and 1. When you look at that information, the cumulative frequency is calculated up to each upper class boundary. Look at the upper class boundary, you calculate the upper class boundary. So if you look at this one, this is the lower class, this is the lower class, and this is the upper class boundary. In other words, you have the upper limit, this is the lower limit. So you're looking at the limit, and then if you look at that, so they are saying that the upper boundary class are 6, 9, 12, 15, 18, and 21. That's the upper boundary class. It's 6, if you look at that one, is 6, 9, 12, 15, 18, up to 21. In other words, upper boundary class, they look at the, for the first one, lower bound is 3, but upper bound is 6. For the second one, lower bound is 6, upper bound is 9. So that's why they're saying that the upper class boundary is 6, 9, 12, 15, 18, and 21. 18 and 21. So the lower boundary of the first class is the 3. That's very true. That the lower boundary is the lower bound. The lower bound is the 3. Where we talk about the lower class is the 3. Yeah. The lower class is 3. This is inserted or completeness like this. Height x centimeters, cumulative frequency CF. When we talk about cumulative frequency, we're talking how many? The cumulative. When you add the first one, you add this one, you add the other one, that's the cumulative. In other words, if you look at that table which is there, the cumulative, the cumulative one, cumulative and frequency are different. Frequency is how many times the number is appearing. That's why you have the first table. But the second one, if you want the second one, where you have got cumulative frequency, they are adding. Less than 3 is 0. In other words, a number which is less than 3 is 0. But from 3 to a number which is less than 6. In other words, from 5 to 3, the number is 1. The frequency is 1. Have you seen that? 1. The other one, if the other one is 1, number which is less than 9, it is 3. The other one less than 12, 14. Less than 20, less than 15, 24, less than 18, 29, less than 21, it is 30. Now what they are talking about there is cumulative. Cumulative for the first one, it is 0, which is less than 3 is 0. Look at this one. What they are doing there is something like this. Less than 3, less than 6. For the first one, less than 3, it is 0. 0, 0. But the other one, less than 6. If you look at the other one, from 3 to less than 6, they are saying it's 1. That one is 1. But for the other one, which is less than 9, it is 3. Where is the 3 coming from? 1 plus 2 is 3. You are accumulating. Remember, here we have got it's something like this. X and the cumulative frequency here. We have that frequency here, and here you have cumulative frequency here. Right? For the first one, which is the first one, it's less than 3 here. The frequency for less than 3, it is 1. Oh no, it's 0. The frequency is 0. Cumulative frequency is 0. Because this is less than 3. Now, we'll talk about less than 6. Less than 6 is 1. Less than 6, the frequency is 1. So, cumulative frequency, 1 plus 0 is again 1. You are taking this plus that, it gives you like. Number which is less than 9 is 2. Frequency for this one less than 9 is 2 here. Now, the fact that this is a 2, cumulative frequency, you are taking This plus that, which is here, is going to be 3 here. Then, the number which is less than 12 is 14. Less than 12, it is the frequency, less than 12. Less than 12, the frequency is 11. It's 11, is this one. Less than 12, the frequency is 11. Now, if the frequency is 11, let's go to the other side. We take this adding to that. So, this one is going to be 14. The 14 is that. That's why the second table, they are talking about 14. There is 14 in there. They are adding. What they are saying, the first one, you take this plus that, then the answer will be this one. The other one, you take this plus that, the answer will be that one. The other one, I'm going to take this plus that, all this, then you add. Then it's going to be that. So this is the cumulative frequency. Right? That's why they're coming up with the second table there. The second table, they're just adding. The first one is 0. 0 plus 1 is 1. 1 plus 2 is 3. 3 plus 11 is 14. 14 plus 10 is 24. 24 plus 5 is 29. 29 plus 1 is 30. That's what they're doing there. Is it okay? Are we together? Huh? Cumulative, but they're just adding. They're just adding. Huh? To come up with this cumulative. The first one is 0, but this one is 1. 0 plus 1 is this plus this plus this is this. This is cumulative. So you're getting that one. So if you look at that one, the last one, it tells you how many the number of plants, the total number of plants. That's why you have got the total number of plants there with the 30. The 30 is coming because of the cumulative. After you have added everything up to the 8, that one, which is the 30, the last one, which is the cumulative, the last total, it is the total number of plants that were planted by that student. Maybe have you seen that? Are we together? Are we together? All right, let's go on. Now, if you want this one, they're saying that now this can be grammatically draw that using what is called the cumulative frequency graph. You can draw that using what is called the frequency cumulative frequency graph. Now, let's look at what is this cumulative frequency graph. Now, if you look at the cumulative frequency graph, it is a graph. For that graph, it's going to be a graph where you have got cumulative frequency against the height of those plants in centimeters. You go there down, they're saying that if you are to draw these cumulative frequency graphs, the cumulative frequencies are plotted against the upper class boundary. So if you look at the upper class boundary there, you are looking at those for the first one, the upper class boundary is we have 3, then thereafter 6, then thereafter 9, then thereafter you go on and on and on and on. So 3, 6, 9, 3 as the upper class boundary 6, 9, 12, 15, 18, and 21 are those ones the one. So the cumulative frequencies are plotted against the upper boundary, and then the points are joined as follows. If you look at that graph which is down there, look at that graph that is down. That graph is a graph of cumulative frequency of the height of the 30 broad bean seeds, cumulative frequency K, to show the height of 30 broad bean seeds. So it's a graph where they are looking at its cumulative frequency against the height. So it's a graph of this cumulative frequency against the height. Now, for that graph, this one, the first, if you look at the number of, if you look at the cumulative frequency there, the cumulative frequency, it has gone up to 20. It has the cumulative frequency. It has gone up to 30. It has gone up to 30. Therefore, cumulative frequency is there. So it is 0, have 0, then you have 10, 10, 20, and you have here 30. Right? And here the boundaries, you are starting it from 3, so you have 0. So you have got something like 0, 3, 6, 9, 12, 15. So up to which one? Which one? 18. You can go on. Of course, let's just simplify this 3, 6, 9, 3, 12, 15, 18, 21. If you are to draw this graph up to there, you will notice that the graph that will come, when, for example, at 3, when it is at 3, there the value is 0. At 3 is 0. So 3 is 0. This is there. 3 is 0. And then at what? 6. 6 is what? 1. At 6 here is 1. Just coming up like that. 6 is 1. Then at around 9 is 3. 9 is 3. It's going up like that. So until when you connect everything, you will notice that's going to go something like this. It's going to go up to something like this. The 30 here is going to correspond to that. When you draw it very, very nicely, it's going to be like a curve of that. The one that we have drawn here. So that you can read it from there. If they ask you, what about if the frequency, cumulative frequency is 7, find what's the length. If it is 7, you go at 7 like that, you read like that, you go like that, and then you find out what will be the value when the cumulative is at 7. What will be the value when the cumulative is at 21? You read it like that. What's the height? So you can read the height when the cumulative is 21, you can read it like that. So something like that. How you read it? Is it okay? Huh? Yes. Okay. So that's the simple address. That one we are using it from that. But let's look at another element here. And this thing that we want to look at is cumulative percentage frequency diagrams. Let's go there. Cumulative percentage frequency diagrams. And you go to cumulative percentage frequency diagrams. Cumulative frequency percentage diagrams. Cumulative frequency percentage diagrams. You look at the cumulative percentage frequency diagrams. Is it now clear? Okay. The cumulative frequency diagrams, we are there now. Cumulative frequency diagrams. Cumulative frequency diagrams. Before I go to that one, what I drew from here, what I drew from here, this one, this is what is called a cave. This one is what's called a polygon. It's a polygon, it's a cave. Sometimes it's known as an orchid. It's this one, it's that's what called a cave. It's this one, that is a cave. Now let's go on to that one, which of course that we are talking about the cumulative frequency percentage diagram. Right. The cumulative percentage frequency diagram, listen, these are diagrams that are used when you want to compare two results. When you are comparing two results, you use what are called cumulative percentage frequency diagrams. Actually, these cumulative percentage frequency diagrams, they are used by this examination board like mine when they want to compare the results of one subject from another, who scored between boys and girls, who scored well. When they are comparing the results, they use what is called the cumulative frequency diagrams. Right. An example is this one that is given there for group data. They are saying, suppose you have examination marks of 200 boys and 300 girls. Suppose you have that examination for 200 boys and 300 girls. In other words, after frequency accumulation, cumulative frequency, they are coming up with the 200. And the other side, they are coming up with 300. Now, let's look at the marks for boys. Marks for boys, those who scored less than 10, they were 6. Scored less than 20, they were 22. Scored less than 30, 60. Less than 40, 140. Less than 50, 172. Less than 60, 188. Less than 70, 196. That's the cumulative frequency. They were adding. You see the first 6, 12, 60, 140. Now the number, when you are on cumulative, the number increases as it goes. It increases, go up, right? It's like the first one is what? Is 60. After 60, then it goes to 22. So it goes to 22, then 140, 172. That is for boys. For girls, for boys, it went up. For boys, the final number is 200. But when you look at girls, the last number is 300. To mean that there were 300 girls. They are comparing the results of two subjects for boys, between boys and girls. Then they are saying, can we find out, let's come up with the wanted to deduce who scored higher marks. Now, if you go the other side, you will notice that the cumulative percentage frequency is now 10. How? Now, after that, those are just the marks for boys and girls. Now, the next thing is what they drew what is called cumulative frequency percentage or cumulative percentage frequency diagram. So cumulative percentage diagram is something like this, the one that is there. Less than 10, it is 6. Less than 20 is 22. And less than 40 is 140. Less than 50 is 172. Something like that. So the cumulative percentage frequency for boys, you look at for boys, for the first one, it is 6 over 200 times 100%. Where is the 200 coming from? 6 over 200 times 100%. Where is the 6 coming from? Cumulative percentage frequency. Where is that 6 coming from? The 6 is the one. Where is the 200 coming from? 200 is the total number of boys that were there. That's what they were 200. You get what I'm saying? Are you also? The first one is what? 6. Are you there? And then if the column of cumulative percentage frequency, look at the cumulative frequency, it is 6 over 200. 6 over what? Where is the 200? How many? The total number is the total number of points times 100. If you are multiplying by 100, the 100%, right? So do that. If you do that, you lose. Huh? Okay. That is a 6 over 200 times 100%. What is that? 6 3%. Right? Yeah. That's 3%. The other one, for 22 over 200 times 100. What is that? 22 over 100, 22 over 200 times 100%. 11%. Right? So, which means you can find the frequency for everything from there. Right? And the last number is what? The last number is 100%. 100%. Because the 200 over 200 times 100. Because 200 divided by 200 is 1, right? 1 times 100 is what? 100%. Right? So that column is the cumulative percentage frequency for boys. For girls, again, it's the same. For girls, instead of dividing it's over 200, they are divided by 300 for girls. They are divided by what? 300. So for girls, the first one is 0. The second one is 2%, right? 0 is nothing because it is 0 over 300 times 100 is 0, right? The other one is 6. 6 over 300 times 100%, right? Which is the 2%. Right? Yeah? Are we together? Yes. Huh? Okay. Now, if you are to draw, if you are to draw a cumulative percentage frequency of boys and girls, look at what they have done there. For boys, they have got 2. So it is a cumulative percentage. The other side. So it is the other side here. It is a cumulative percentage. Cumulative percentage here. Cumulative frequency percentage over max here. Over max for boys and girls. If you look at the first one, the first graph is for boys. If you have to go to that graph, it's going to be like that. That's for boys. Right? No. This graph is for boys. Right? The second graph is for what? Girls. But they are taking numbers, they are taking numbers based on cumulative percentage. They are not cumulative percentage. The last number is 100%. They are using that. Right? Now, if you compare the two graphs, there is the first graph here, and then for the second graph. This is for girls and this is for boys. If you compare, you may get tempted You may think that the boys perform well than girls. Or you may think girls perform well than boys. You can be tempted to think that from the graph, if you look at this graph, you may think that boys perform well because they at least they went more than 100. They have gone up in 100. That's why they are performing well than boys, than girls. You may think like that. But for you to know who performed well, it's better you come up with another now table. Instead of this one, the first this table, come up with the frequency density table. Go to another page, the other page. Table. The other table, the frequency density table. Let's go to the frequency density table. This one. Where they have got it, cumulative representing frequency, 3%. The 3% is this one that we are looking from there, right? This is for boys, and we are looking at for boys, right? 3% is this one. So, because it is less than 10, they are start saying it's 0, 0, 9, 0, 9 is something is 3%. Right? Then come up with the frequency density. Frequency density, how we calculate frequency density? It is it's 3%, right? It is a 3. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 of them, right? Yeah. So it is 3 over what? 3 over 10 times 100%. Do that, find out. 3 over 10. You know the 10 is where the 10 is coming from. Because they were 10. 1, 2, 3, 10, right? So it is 3 over 10 times 100%. Find out for the first one. We are looking at the density. Another column. We are that's a column where we have now come up with another density column. The first one is, this one is 3 over 10 times 100, right? What is it? 0.3, this one. Huh? Then, where is that coming from?
3 over 10.
Yeah. Is what? 0 over 10. Oh, the example is what? Oh, is that? Alright. 3 over, no, 3% is 3 over 100. 3 over 100 times what? Times 10. Not the 3. 3% is 3 over 100, right? You are multiplying by total number of 10. 3 over 100 times 10. Because there are 10 items there. 0.1? 0.3. For the other one, what will be the other one? Let's take for the other one. Over 100 times 10. Number 8. Is it coming? Which means you can do for the whole of this, right? You can do for the rest of this, right? This is for boys, right? Volume over right. This one 0.3. It is 3% times how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3%, so it is 3 over 100 times 10. 10 times 10. 10 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this is 3% times 10 times 12. Can you do it? We are looking at this, the frequency density. So what? Yeah. So you can do the next, the whole list, right? Now, what are doing there? You are calculating the density for both the boys and for girls. This is for boys. Both for girls. Check for girls whether what you are finding is the same. Huh? For this one, where here the density. You're not getting where? No. If you look at this one, it's fine. You are getting. But what about here? How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For the first one, 0% times 10 is 0. The second one, 2% times 10. 2% times 10 is this one, 0.2. Right? You can get, in other words, the density there, you can get the density for boys and density for girls, right? Is it? You can get density for boys and density for girls.
Yes.
Right? Go to the down, you have the graphs. There are two graphs that have been done now. The bar graphs. We have got two graphs, the bar graphs down there. One is for boys, another one is for what? Girls. And this one is frequency density against mass for boys. And another one is frequency density against mass for girls. Right? Huh? Have you seen that? Now, if you look at those two graphs, you will notice that the way the graphs are appearing is different. Look at the first one. The first one is something like the graph is something like this. The first one is something like this. It goes something like this. Have you seen that? The first one. Right? When you look at that one, if you look at this one, it's going to the, this one is the left or right? Huh? Is skewed to the right, right? Yeah. So this one is skewed, we call skewed. It is skewed to the what? To the right. Look at the other one. Look at the other one. The other one, it is skewed to the what? To the left. Now, what does that mean? If you look at this one, which is skewed to the left, this one, it means, let's look at this one. The other one, it is something like this. Something like this. Something like this. Something like this. Right? The other one, something like that. You will notice that when you look at that graph, this one, it has got the highest peak and the numbers that are found here, right? This is for girls. For boys, the highest peak is just closer to the small numbers down here. Which means if you are comparing the two, it is the girls who are performing better than the boys. Because look at the girls here, a lot of them, they are at this side. It means that they are performing well than the what? The boys. The boys are just close to this number here. So they are performing badly than the girls. Girls, they are performing well. This one will tell us that if you look at the two, it will lead us to where what we call skewedness. The way it is skewed, it is how the graphs are, how they have been appearing. If you look at like this one, let's look at this one. This one is skewed to the left. It is skewed to the left. This one is skewed to the left. In other words, it's negative skewed. This one is negative skewed. If it is negative skewed, you discover that a lot of them they are hidden. If you look at that one, a lot of them, which means this as if this one has this it means that they have done very, very well. But if you look at the other one, so if I am to draw the graph, it's something like this. It's something like this. Means a lot of them they are here. A lot of them they are here. That they have done very, very well. These ones are the ones that they have done very well. But if you look at the other one, the other graph, which is something like this. This means it is skewed to the right. So this is skewed to the right. It is skewed to the right here. When it is skewed to the right, it means a lot of them they are here. It means that they have performed badly. So this means that they have performed badly here. Performed badly. Why performed badly? A lot of them they are just within here. There are very few who are at this side. But for this one, there are a lot of them that are within this part here. And this one is skewed to the left. Skewed to the left. In other words, skewed to the left is called negative skewed. This is called negative skewed. But this one, skewed to the right, this one is what is called positive skewed here. So we'll be looking at this skewedness later. And again, there will be other time, instead of skewed to the left, skewed to the right, there will be other time when this will be normally distributed. When it is normally distributed, it means that boys and girls they have performed the same. So it means that there will be a tail like this one. Where you have got a tail like this one, it means that that is normal distribution. This is what's called a normal distribution. It's going to lead us to the normal distribution. In a normal distribution situation, it's where now that boys and girls they have performed at least equally. That's a normal distribution. There is this one. But in this situation, it means that girls they have performed very, very well. Then this means that boys have performed badly than girls. Therefore, you cannot judge whether the boys have done well if you come up with this graph that we did for the first of that one. First graph and second graph. For us to know who has done well, you look at this one, you have to use what is called this distribution graphs. So our next lesson that we will look at when we meet, we will be looking at now whether positive skewed, negative skewed, or normal distribution. So the skewedness. You can either positive skewed, negative skewed, or normal distribution. I think this is the word that we look at here. The skewed. It can either be this one, negative skewed, this one, normal, symmetrical, which is known as normal. The word normal distribution is sometimes referred to as the symmetrical distribution. because that is the symmetrical distribution. And the other one, it is what? Skewed with the what? With the positive skew. So we have got the positive skew is this one is the negative skew. And for this skewedness, it will tell you whether, because when you are looking at the skew, it's where when it is normal distribution here, the mean, mode, median are within. When mean, mode, or if you are calculating mean, you find that mean is mean is a 2, mode is a 2, median is around 2. When you find that mean, mode, median is just a little the same, it means that is normally distributed. When you calculate and find what is mean. You know what mean is? It's the average. You know what mode is? Mode is a number that is appearing frequently, right? And you know what the median is? It's the middle number, right? If there are two, you add them, divide by 2. So when you find the mean, mode, median, when you get them and you discover that they are just the same, that is what is called asymmetrical. We call it asymmetrical, or sometimes we refer that one as a normal distribution. So normal distribution is coming in because mean, mode, median is just. But when mean is less or mean is small, we come up now with this scenario here. When mean is small or mean is less than median or than mode, is when we come up with whether it is positive skewed or negative skewed. But in a cumulative frequency graph, you cannot just come up with that frequency. You have to calculate the density for you to find who has done very well. And you can know that when you come up with now those graphs that are there. When you have those graphs, can tell you whether who did well and who did not do well. I'm done. Are you following? Huh? What have I said? What have I said? Yvonne, what have I said? This. Madam, what have I said? Yeah, everything. Everything. Tell your friends, what have I said? What's the time now? Huh? Past